So here's another example of where we can use L'Hopital's rule. We're going to evaluate the limit as x approaches 0 of x minus sine x over x cubed. Now notice, incidentally, that we first have to verify that this is, in fact, that L'Hopital's rule in fact applies. In other words, that this is a 0 over 0 or infinity over infinity limit. What we can see is that substitution is going to yield 0 minus 0, because sine of 0 is 0, so we get 0 minus 0 over 0 cubed. So we do in fact have substitution in fact does give us 0 over 0. So we can check that off. We do have a 0 over 0 limit. So this limit is equal, by L'Hopital's rule, to limit as x approaches 0 of the derivative of the top is going to be 1 minus cosine x, and the derivative of the bottom is going to be 3x squared. So now let's try substitution. Cosine of 0 is 1, so we have 1 minus 1, that gives us 0 on top, and 3 times 0 squared is still 0. So once again, we have a 0 over 0 limit. So what do we do? It didn't seem to help. The answer is, we can just do it again. Because we now have a function, and L'Hopital's rule asserts that since substitution gave us 0 over 0, this will be equal to the quotient of the derivatives of these functions. So let's just try it again. And we are now doing another L'Hopital's rule step, because L'Hopital's rule is going to assert that that limit is equal to the derivative. I'm going to take the derivative of the top and the derivative of the bottom. So that's going to be 0 minus negative sine x. So that's going to be sine x over 6x. And we try substitution again. Sine of 0 is 0. 6 times 0 is 0. So once again, we have 0 over 0. So what do? We do it again. I'm not guaranteeing that every time that you keep doing L'Hopital's rule you're going to get an answer. There are some where you don't. There are some where you just keep chasing your tail forever. But sometimes you may have to do it 3 or 4 times to get down to a form that you can evaluate. So this is going to be the limit as x approaches 0 of derivative of sine is cosine. The derivative of 6x is 6. And now, by substitution, this is going to be cosine of 0 is 1, and 6 is just the constant 6. Now if I wanted to do something wrong, I could put the LHop there. Why is that wrong? Because I'm not taking the derivative of cosine x and the derivative of 6. I'm simply performing substitution. So the limit of x approaches 0 of cosine x over 6 certainly is equal to 1/6, but not because of L'Hopital's rule. These steps are equal to each other because of L'Hopital's rule, so I've put the LHop over the equals sign.